Hi Calculus student, this video is for chapter 4.5, part 3. We are working on concavity tests. In part 1 we do first derivative test, which is to find increasing, decreasing, local max and min. The second derivative test we find when the graph has concave up and concave down, and also point of inflection. So this is the second example. Function is sin x minus cosine x. It's a trig function. So we want to find out when it's concave up, when it's concave down, and when it has the inflection point. So we say using concavity tests, we would work on the second derivative. So do the first derivative first, which is cosine x plus sine x. And then we work on getting the second derivative, because for concavity test we use second derivative, so it will be plus cosine x. It seems nice to go back to the original one, right? Do you feel that? So to find the critical point for f double prime, we would just set this equal to 0. So that means sine x is equal to cosine x. In other words, tangent x is equal to 1. Right? If you divide cosine x on both sides, and we just know that if cosine x cannot be 0, because if it's 0, the other one is not. So if you plug in 0, it is not a solution, so we can divide it. It's tangent x equal to 1. So what they didn't tell us what intervals. I'm gonna just do from 0 to 2 pi. Let's say from 0 to 2 pi, because there's tons of them. So there's two numbers from 0 to 2 pi where tangent x is 1 is pi over 4 and 5 pi over 4. In the unit circle is the quadrant 1 and 3. Right? So we have these two, and then we will use this to do the number line. Pi over 4, 5 pi over 4. And then our testing would be on this one, right? Or actually on, yeah. Okay, so let's look at sine less than pi over 4. So pick a number, pi over 6, right? X is equal to pi over 6. If I plug in negative sine of pi over 6, that would be negative 1/2 plus 3 over 2. That is positive. And then what is between pi over 4 and 5 pi over 4? That would be pi. So negative pi sine pi plus cosine pi. This one is 0. Cosine pi is negative 1. So it's negative. What about a number that's greater than 5 pi over 4? So we pick 11 pi over... No, 5 pi over 4 is the third quadrant, so we can do 3 pi over 2. Just easier. Okay, so negative sine 3 pi over 2 plus cosine 3 pi over 2. In the unit circle, what happened? At 3 pi over 2 is 0 comma negative 1, right? So 0 comma negative 1. Oh, it's positive, because negative of negative 1 is 1. So it's positive. So you just use f double prime to test what you have. This is f double prime. Okay. And then f double prime is like this. So it's increasing, increasing, decreasing. Absolute max. Oh no, this is not increasing. This is concave up. Mess up. That's first derivative test. It is concave down. And this is concave up. Okay, and then we have two inflection points. Inflection point at here and inflection point at here. So a lot of answer to write down. So concave up from 0 to pi over 4. Union 5 pi over 4 to 2 pi. Okay, concave down is pi over 4 to 5 pi over 4. And what is our inflection point? There's two inflection points. One is pi over 4 something. If I plug in pi over 4 in the original equation, it will be root 3 over 2. Oh, it's 0. Root 3 over 2 minus root 3 over 2. And then also 5 pi over 4. Also 0, because both of them are negative. So we have two inflection points. So let's do one more example, which is to figure out everything for one function. 6 things, increasing, decreasing, local max and min, which using the first derivative test, and then concave up, concave down, and inflection point using the second derivative test. So we combine everything together. So don't mix them up. So first of all, first derivative test. Okay, let's write down first derivative test. For first derivative test, we want to do f prime. So f prime of x is equal to 12x to the cube minus 24x squared minus 36x, right? Do the first derivative. Have it equal to 0. So factor the 12x out. X squared minus 2x minus 3, right? And it is factorable. 12x, x minus 3, x plus 1. Okay, this is factorable like this, using the diamond method. Okay. Negative 3, negative 2 is negative 3 and 1. So then equal to 0 would be x is equal to 0. That's a lot of number. X equal to 3 and x equal to negative 1. Label them according to sequential order. Negative 3, 0, 1. If you switch them around, it doesn't work. Now you want to test the sign. So I pick some test point, x equal to negative 4. If I put in 12, negative 4, negative 4 minus 3, negative, negative, negative 4 plus 3, it's going to be negative. If I plug in x equal to negative 1, then it will be 12, negative 1 times negative 1 minus 3, both are negative, and then, oh, negative 1? Did I solve wrong? Oh my gosh, I solved wrong. I'm just going to erase it instead of typing it again. So this would be actually x equal to 3 and x equal to negative 1. X equal to 3 and x equal to negative 1. I can reuse the first negative 4 testing. I factor right, but I solve it wrong. X equal to 3, x equal to negative 1. So this should be negative 1 and this should be 3. So I should not pick negative 1. I should pick negative 1/2, right? So it'll be negative 1/2, negative 1/2 minus 3, negative 1/2 plus 1. So this is negative, and this is also negative. If I have this negative, 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 this is plus 1. Minus 3, so all these are negative, so it's negative. If I put in negative 1/2, is there one that is positive? Oh, actually this one is positive. And these two are negative, so I do have a positive. Okay. And then test again. X equal to 1 here. So it will be 12 times 1, 12 times 1. 1 minus 3, that's negative. And then 1 plus 1, that is negative. And then I pick x equal to 4. Everything is net positive. Times 4. 4 minus 3 is positive. 4 plus 1 is positive, so the whole thing is positive. So that's the first derivative test. So I have 2 increasing, 2 decreasing, right? And then I have the local mean. Wow, it's really long. Increasing from negative 1 to 0, union 3 to infinity. Decreasing, because it's x to the 4th. Decreasing is from negative infinity to -1, union what? This is also decreasing. 0, 3. Local max is the one that is 3 comma something, and local mean is the point here, -1, -1 comma something. Oh, there is another no, this one is this is not a max. The max is 0. Oh, if I plug in 0, that's 0. Mean, there's 2 mean, this one, -1 and 3. And local mean, another local mean is 3 comma something. So which we will work out by putting into decimal, right? We can do those. Just find out what it is when f of -1. We'll just say f of -1 and f of 3, right? For the sake of the completion. And then I have to do concavities, which is f double prime. Do I have enough space? So maybe we'll use the space over there. F double prime x would be, you do not use this factor form, you use the like this one, that pre-factored. So 36x squared minus 48x minus 36, right? So what is the best way to factor? Factor 12 out. 3x squared minus 4x minus 3. Is it factorable? I'm not sure. Probably not, because 9. I don't think this is factorable, so that's kind of difficult to do. So let's consult our did I do something wrong? This is 24, 12x cubed. Okay, so this is not factorable, and I find from the calculator that the two roots for this is x is equal to negative, using quadratic formula, 0.53, and then x is equal to, it is like square root of something, 1.869. So we'll just do the same thing. We'll just do, but this is f double prime, right? What is it? So we have the negative 0.53 here, and then the 1.869 here, and we do the test. Okay. You can think of it as, you know, -1. If you plug in -1, what do you get? -1, -1. This is a square. Okay, it's 3 times -1 minus 4 times -1 minus 3. So that would be -3 plus 4 minus 3 is negative. Is it negative? -1, 3 times negative. Oh no, this is a positive 3. So it would be 6. No, it would be 7 minus 3. 7 minus 3 is positive. Okay. And then if I plug in a big number like 2, so I would plug in 3, 2 squared minus 4 times 2 minus 3. So 12 minus 8 minus 3. That's also, yeah, that's minus 11. So the last one is also positive. If I plug in 0, everybody knows that it's negative because it's a negative here. So we would have concave up. Oh no, this is negative, not 0. And then we have two inflection point. So basically the same idea. If you test f double prime is positive, it's concave up. You test negative, it's concave down. And then the point where there is change of concavity, that's inflection point.